G'day again. In this video I'm just going to look at more tricky mod equations. Okay, so let's just have a think about this. Just before I start, I had, if it was x plus 3 equals 10 or something like that. Just remember that what we're looking for is when the stuff inside the modular sign, when is it positive, when is it negative, and what happens in each of those situations. So what we're looking for when x plus 3 is greater or equal to 0, in other words, when x is greater than negative 3, or we're looking at when x plus 3 is less than 0, in other words, when is x less than negative 3. So you'll see that the behaviour changes when x goes through this point negative 3. The behaviour changes at that point. And so whenever you see a modulus like this, you can sort of see, well, look at this, the behaviour is going to change at negative 3. If it was x minus 6 equals 9, the behaviour will change at the point x equals 6. So it'll be what happens when x is greater than 6, what happens when x is less than 6. So that's what we're looking at here. So with that in mind, let's have a look at a tricky equation. So let's just do this one here. So x minus 4 minus x plus 2 equals 6. Okay, so here we go, a tricky one. We've got a double, and so it's not as easy to actually think about. But what we've got to sort of think about is, if you think about it on the number line, when will this equation change behaviour? What I just said is that this part here will change behaviour at the point 4. So let's mark that on there. So at the point 4 here, it'll change behaviour when it's less than this, and it'll change behaviour when it's greater than this. This part here will change behaviour at the point negative 2. So it'll be something different down here to up here. So basically what this means is that we need to consider 3 different regions. What happens in this region here, what happens in this region here, and this region here. And that's what we need to consider. So we need to take each part one at a time. So let's do this. So firstly, let's start down low. If x is less than negative 2, okay? So x less than negative 2. Let's have a look. What happens? If x is less than negative 2, what is this part? So x minus 4, will that be positive or negative? If x is less than negative 2, like say negative 10, that'll be negative. So what does the modulus sign do? It times it by negative 1. So we have negative x minus 4. Awesome. Minus. What is it happens down here? We've got x plus 2. So let's take a number that's less than negative 2. Let's say negative 10. Negative 10 plus 2, that is still negative. So that modular sign is going to times it by negative 1. So put another 1 into there. And so that's the equation we get if we're in this particular region here. So let's just solve this. I'll try to get as much space in here. So negative x plus 4, that turns into a plus x plus 2 equals 6. What do we get here? The x's cancel out, and we've got 6 is equal to 6. Oh, amazing. What does this mean? This means that it doesn't matter what x is equal to, this is always true. In fact, that means that x is less than negative 2. So in other words, any number that's smaller than negative 2 that you can choose will always be true. Always. Cool. So it doesn't matter what the value of x is, that will be true. Let's have a look at what happens in the middle region here. Okay, so let's have a look. If x is less than 4 but greater or equal to negative 2, sorry to squish that in there, I just got it in. Let's have a look at what happens. So just take a number, let's take 0. 0 is in that region, let's just see what happens. So 0 minus 4, so that will be negative in there. Okay. What happens when it's negative? We need to times it by negative 1 to make it positive. That's what the modular sign does. Minus. What happens to a number that's in this region here? So 0. 0 plus 2, that'll be positive. In other words, that doesn't get touched. So x plus 2 doesn't get touched. The modular sign doesn't do anything. Equals 6. Okay, so again, let's just solve this. So minus x plus 4 minus x minus 2 equals 6. Therefore, let's do it quickly. So minus 2x, I can't do it quickly under pressure. You guys have got me. So negative 2x equals positive 4, negative 2, that's positive 2. put it that, minus 2, so minus 2 equals 4. So therefore we get x is equal to negative 2. Let's just check that this makes sense with the region that we're talking about. It always just pays to find out. So what we're saying that if x is in this region, then x must be equal to negative 2. Okay, so that makes sense. That's okay. Let's have a look at our last region. What happens when x is greater or equal to 4? Good. So let's say 10. 10 is a number that's in this region. 10 minus 4, that's always going to be positive, so that does not change. Minus x plus 2. 10 plus 2, it's going to be a positive number again, so that doesn't change either. 6. Okay. Fantastic. Let's expand it. X minus 4 minus x minus 2 equals 6. Therefore, x minus x, we get negative 6 equals 6. No, that is never true. What this is saying is it doesn't matter what the value of x is that you use, this is never true. Okay, therefore there's no solutions here. No solutions in that range. So looking at the three regions, let's put it all together. Let's put this three information together. Okay, so let's have a look at it. This is saying that x can be less than negative 2. And this is saying that x can be equal to negative 2. And this is saying that if x is greater than 4, no solutions. Therefore, if you put them together, we get x is less than negative 2, but it can also be equal to negative 2. And that is your answer for this particular question. So just to summarise, firstly, figure out what your points are where the modular sign will change behaviour. So in this case, it was positive 4 and negative 2. That's where it changes behaviour. Look at your three regions. For each region, figure out what's going on. You get a solution. If you get something like 6 equals 6, which is always true, then that whole entire region is true for anything. It doesn't matter what x is equal to. If you get something that is never true, then there is no solutions in that region. You can't. There's no x that satisfies that particular equation. And then if you get a particular solution here, x is equal to negative 2, then that gives you a solution. You put your solutions together, and that's your answer. Hope that makes sense. In the next videos, I'll do some inequalities with our lovely modulus. Modulus I? Something like that.